Okay, this is lesson 5. What in the world? Lesson 5.2, friends. Systems, but let's work on solving them algebraically by substitution. Now, let's hope that I spelled that wrong, right? Or spelled that right, huh? So remember how we talked about that graphing is not the best way of solving. So this is one of the ways to solve is by using algebra. So we're going to actually find the exact numbers that we're looking for. So the method we're going to use, I'm going to introduce to you today, is substitution. Okay, substitution, just like if you had a substitute, you would, I would be replaced by another teacher. So that's what you're going to do is you're going to substitute. So the goal is, number one, that you solve. So here's your step. Solve for one variable. Okay, get one of the variables all by itself. Number two, sub into the other equation, and sub again. And I thought what I'll do is I'll just go ahead and I'll model it. So here's your systems. So, okay, and then 6x minus 5y equals negative 19. Okay, got to get my highlighter out. You know I like to use colors, right? Okay, so first of all, using substitution. So you're gonna practice all of these, but you want to look, do I have one of my variables in either one of my equations? Is it solved for just the variable that has no letters or anything out? Okay, well, first of all, this has coefficients, so these two are out. How about over here? Oh, hey, look, this y is already solved all by itself. So I'm going to take this piece right here, that y equals, and I'm going to substitute it. So this is step number one. I'm going to substitute it in for the y right here, because see, y is equal to that. So I'm literally going to take this piece and I'm going to substitute it in for the y in this equation. Just like if I had a substitute, that person would come in and replace me for the day, right? Now, what do you notice about this equation? What letter do you see here? Do you see a y here anywhere? You don't. It's all x's. So check to make sure that you don't have still an x and a y. You should have all one letter, okay? Now, what do you think we're going to do with this negative 5 here? You're right. We are going to distribute. And I'm going to circle this negative 5 because I want you to distribute that whole negative, okay, to each of these pieces here, okay? So here we go. 6x. So negative 5 times negative 2 is a positive 10x. And a negative 5 times a negative 9 is a positive 45 equals, whoops, that's a 5, equals negative 19. All right, before you get started, okay, let's collect like terms if we can. Well, I have 6x and negative 10x. I don't have to add the opposite. I can just gather my like terms. So 6 plus 10 is 16x plus 45 equals negative 19. All right, let's get x all by itself, friends. So we're mushrooming this out, or onioning this out. Mushrooms don't have layers, do they? 16x is equal to, so 2 negatives, so that's a 4, negative 64. Divide by 16, and x is a negative 4. Okay, I'm going to use a different color. I've got my x, I'm all done, right? Well, no, remember that this is where two lines cross. So if I have to figure out the point, don't I need an x and a y? Well, I do. Well, here's the fun part. Look, You have the y right there. All you got to do is take this and plug it back in to the top. So x was a -4, right? So y equals -2 times a -4 minus 9. So y equals -2 times -4 is a +8 minus 9, and 8 minus 9 is a -1. Y is a -1. Let's write it as a point. -4, -1. So these two lines intersect at -4, -1. And I know that for a fact. I don't have to worry about that I graphed it wrong. That's exactly where those two intersect. Okay? That's all that we're dealing with, okay, throughout all this. All right, let's try another one where we actually have to solve. So let's try this one. This one's going to be, okay, where you get some choice, okay? So I like doing some choice, okay? Okay, take a look at this. Okay, we're going to have lots of practice. So remember that we want to do it by substitution. Okay? What variable would you like to get all by itself? Because there is no variable like what I had up top, right? It's not x or not just y equals. But could I make one of these equations like that? And if so, which one would you choose? Well, what about if we take the top equation and we get y all by itself? Okay? Well, in order to get y all by itself, okay, I'm going to just rewrite this over here real quick. If I want to get y all by itself, I need to get rid of that x, don't I? So let's add x to each side. So I get y equals 3 plus x, or you could write x plus 3. Doesn't matter, does it? Okay? Now that I've done this, I can take this and I need to substitute it into the other equation. Be careful. Sometimes kids want to plug it right back in. That's not going to work, okay? I want to plug it in to this y, okay? This piece here. So here we go. 3x plus 3 plus x. Now I like to put that in parentheses so you can see what's being substituted, okay? A little bit easier. Okay, let's check. Do I have all the same variable? Yep, x's. Okay, do I have to distribute? Oh, I don't even have to distribute here. 3x plus 3 plus x equals -1. All right, can I collect any like terms? Yep. 3x and an x makes 4x plus 3 equals -1. Let's get this all by itself. Minus 3. I get 4x equals -4, divide by 4, and x is a -1. Okay, am I done? No, I'm not done. Okay, here we go. This should be easy. Right here. Look, see, if I box these in, see how my eyes go back here? This is pretty easy. Y equals 3 plus, instead of x, I'm going to put a -1, because that's what I got, right? So what's 3 plus a -1? Y is equal to 2. All right, write it as an ordered pair. -1, 2. Okay, that's it. That's all. Thanks, friends.